Welcome to RGES Algebra 2. This is lesson 28B, and we're going to be discussing section 8.9. Now, before we do that, let me just look at this scripture with you. I found this scripture in my, as I was doing my devotion yesterday, and I thought it was so encouraging. It says, "When the earth totters and all its inhabitants, it is I who keep steady its pillars." And so this is very encouraging to me, because we certainly can be said to be in a time right now where the earth is tottering and the people are being shaken. So the earth is tottering, the people are being shaken, perhaps even some that you know, perhaps even your own heart feels shaken at this time. But there is a great promise hidden in the scripture, and it says, "It is I, the Lord." He's the one who's speaking. "It is I who keep steady its pillars." So even though we feel as though everything is shaking and getting ready to fall down, perhaps we could be feeling that way, be encouraged. God is still on his throne. He is still in charge. He will steady the pillars of society, the pillars of the nations once again. He will keep it steady. So put your trust, in the Lord. Lean into him during this season. So the next thing I'd like to do is look at your answers to your homework. You were asked to do 8.7, 1 through 25 odd, and the word problems, and 8.8. So go put it on pause if you haven't already brought those things with you, and get ready to check your answers. So 8.7, number 1 is 6. Number 3 is 36 times the square root of 2. 5, 3 times the sixth root of 72. 7, 12 times the square root of 5. 9, 10 times the sixth root of 32. 11, 3ab squared c squared times the sixth root of a b to the fourth c squared. 13, 2/3. 15, 1/2 the sixth root of 2. 17, 6xy squared times the square root of 2x. 19, x to the negative third, or we could put it in the denominator, y squared times the cubed root of xy squared. 21, -1. 23, 48 plus 13, the square root of 5. Let me try that again. Number 23, 48 plus 13 times the square root of 15, and 25, -7. I think I'd like to do the last two for you in this section, 23 and 25. We've already done many, actually, over the last couple of tapes. So if you have any other questions that you have not been able to resolve, remember the other option is, after I've done these two, is always text me. Text me and ask. Had no questions, so I'm trusting you're keeping up and that you're understanding everything. All right, so text me 505-301-1357 if you have any questions about specific problems that I do not cover. Now, number 23, let's go over that one together. 2 square root of 3 plus 3 square root of 5. One binomial times 3 square root of 3 plus 2 square root of 5. This will be a good review for what comes next. Now, of course, what we want to do is FOIL. First terms, we're going to have our 2 times our 3. That will be 6. Square root of 3 times square root of 3 is 3. Okay. Outer terms, we're going to have plus 4 square root of 15. Inner terms, we're going to have plus 9 square root of 15. And last terms, so that would be the inner terms. And the last terms would be 6 times 5. Square root of 5 times square root of 5 is 5. So we take these two, we multiply them. That would be 18 and 30, and we're going to add those together. So this would be 48. Both the middle terms have the same, have similar terms, so we can add them, okay, because they have the same index, same radicand, and so that would be plus 13 square root of 15, and that's my answer. Let's do the next one. I should recognize this as a pattern. They have the same two terms. Only difference is the sign, a plus and a minus. Okay. So that means middle terms will drop out. Square root of 5 times the square root of 5 is 5. Prove it to yourself. Plus 2 square root of 15 minus 2 square root of 15. They drop out. Okay. And then so you just move to the last term. 2 times 2 is 4. Square root of 3 times square root of 3 is 3. We have 5 minus 12, which equals negative 7. Okay, we're going to be using those ideas. That's why I wanted in particular to do those. Now let's look at the word problems for a minute. Number 41 says, if real coffee costs $5 a pound and Java coffee costs $7.50 a pound, how many pounds of each must be bought to fill a 120-pound canister with a blend worth of $7 a pound? So what will my equations be? Well, first off, I have a 120-pound canister. So the amount of Rio plus the amount of Java together will be 120 pounds. Now remember, we're always saying we're looking for two different ideas. This has got to do with the amount, and the next one's going to have to do with the cost. And that's a very easy way to start looking at these problems. So what would be the cost of R? Well, it's going to be 5 times the amount, $5, right? And the cost of the Java will be $7.50 times the amount of Java. And altogether, the cost will be, where did it go? $7 a pound. Now that's a little tricky. Why is that tricky? Well, it's going to equal 7 times the amount of both, right? Okay. So we need to write in there R plus J. Okay. So here's my first equation, and here's my second equation. So to solve that, I think I would probably be inclined, no, it doesn't matter really, maybe I'd probably be inclined to solve for R, let's say, and then plug that into here. I think that you know how to do that. Now, the other way you could do it, of course, okay, is to distribute this through, and then you'll have a 0 on the right-hand side, but that's all right. Let me show you that way, just because it's not one you're used to as much. If I distributed the right-hand side, I'd end up with 5R plus 7.5J equals 7R plus 7J. Taking them to the left side, I would get negative 2R minus the 7 is plus 0.5J equals 0. Taking this one down and multiplying it by 2, as I do it, I'm going to get 2R plus 2J equals 240. Adding, I'm going to get 2.5J equals 240. And so that'd be, let me check it, 96 pounds for Java, and together it's 120, so Rio would have to be 24 pounds. So hopefully this is becoming clearer and clearer with every word problem you see. Let's look at the next one, 42. If a rectangular floor were 2 feet wider and 5 feet longer, its area would be 140 square foot greater. If it were 7 feet wider and 10 feet longer, its area would be 390 square feet greater. Okay, so that's kind of a fun problem. What would we do? Well, I'm basing this whole thing on the idea that the regular width times length is my area, right? And so for the first one, if the width were 2 feet greater and the length were 5 feet longer, see how I get that? I'm going to get the old area. Whoops, I'm sorry, I should put W first. W times L. It's going to be greater than the old area. How much greater? 140 square feet greater. Does that make sense to you? That's scenario number 1. Scenario number 2 you could probably do now if you weren't able to do it before. If it were 7 feet wider and 10 feet longer, comparing to the old area, it would be 390 greater. Okay, so what would you have to do then? You're going to have to, there's several things I can do here. This is, so you might have paused at the beginning thinking, do I know how to solve this? But you do, because you just use FOIL to come down here, and now you have a WL on both sides, so they can just cancel out. So now this looks like the kind of equation you're very comfortable solving with simultaneous equations. So the same thing would happen when you do the next one. Okay, so I'll leave the solving to you. I don't think that's going to be problematic after we show you that first step there. The length should equal 20 feet when you're done, and the width should equal 18 feet. Now again, if you can't get it, even though we've shown you that first step, feel free, of course, to just go ahead and ask for it with your text, and I'll show you the additional steps. Now, number 43 says, 2 contestants run a 440-yard course. The first wins by 4 seconds when given a head start of 200 feet, and they finish together when the first is given a head start of 40 yards. So be careful, because we've got feet and yards. So for these, this kind of equation, or this kind of problem, you have to fall back on this equation, rate times time equal distance. We're talking about distance, okay? He wins by 4, well, we're talking about a lot of things, okay, here. But, so if I have rate times time, I can set it up here. The rate on the first guy, which would be x, this is going to be the rate of each. I can set it up different ways, but I'll do that, okay? So the rate of the first contestant times his time is what? 4 seconds less. I'm sorry, wins by 4 seconds, that's right. He's going to be 4 seconds less when given a head start of 200 feet. So he has to run 200 feet less, and then he will equal the right-hand guy, the second. The second guy will be y times t. Okay. Now for the next equation, they finish together when the first is given a head start of 40 yards. So convert yards to feet, and so we don't talk about the So we're going to just have xt, right? The time will be the same when, but he's given 120 less feet to run, so we have to convert to feet. Okay, and then they'll be the same. So to solve that, then what do you have to do? Okay, you're going to distribute that through. Notice my xt's will drop out, and I'll end up with x's and y's. Do you see how that'll work? In fact, rather than me doing this one, I want you to play with it, because if you just do this distribution, line them up and do linear combination, adding down, you're going to see what happens, all right? And so I think that's worthy of you taking the time to experiment with that. So my x, the first guy, is 20 feet per second. And my second guy is going to be 22 feet per second. Okay, let's move on to 8.8 to give you your answers to your questions, or your problems that you've done at home. It's 1 through 27 all. And again, I believe we showed a fair number of examples here. So let's go ahead and get these. The answer to 1, which I did do for you, is 3. Next is square root of 3. Next is 4 times the square root of 3 over 3. Next is 3. Next is 2 times the square root of 2. Next is 7 times the cubed root of 15. Next is the square root of 30 over 2. Next is the square root of 2 over 2. Next is 2 times the cubed root of 15. Number 10 is 2 times the sixth root of 5. Next is 3 times the square root of 2 over 2. Next is the sixth root of 18. 13 is the sixth root of a squared x to the fifth, y to the third, all over xy. Number 14 is y times the square root of 2. Number 15 is the square root of x squared minus y squared, all over x minus y. Number 16 is the sixth root of 2xy. Number 17 is the sixth root of 3ab. Number 18 is the 12th root of 2xy. Number 19 is the square root of 1/4 over, I'm sorry, I was reading the problem for number 19, I apologize. Number 19 is the square root of 2 over 2. Number 20 is the sixth root of 45. Number 21 is 2 times the sixth root of 12. Number 22 is the sixth root of 3 over 6. 23, the square root of 6 minus 1. And number 24, 2 times the square root of 3 minus the square root of 6 plus 2. And number 25 is 1 over 16. 26 is a word problem. And 27, I'll do those at the end. Okay, so we have done several. And I'm trying to think what you might need me to do here. Let me pause and choose a few more examples for you. Now, I tend to do these a little bit different than the answer key might show. They tend to actually pull this under first. So I'm going to illustrate that because they're both cubed root. I could look at that as the cubed root of 54 divided by 2, do my division. The cubed root of 27, and the cubed root of 27 is 3. Either way, okay, in this particular example, that probably is faster, so I think it's sometimes good to see more than one way to do something. Let's look at number 5. So when I do this one, I break it into primes, pull the ones I can out, every pair, and then simplify what's outside. That would be the 2 here. And then now this can be, of course, the square root of 6 over 3, which is the square root of 2. All right, let's look at another. Now here I notice that 9 divides into that. So, I'm trying to illustrate different ways to approach the problem. Okay, so this one then I would tend to go like this. The cubed root of 135 over 9, which goes in 1 and 45 is 5. The cubed root of 15. Okay, when I divide that, and so we'll have 7, the cubed root of 15. As my answer, let's look at 14. Okay, I think here I would tend to simplify this first, so and then go ahead and pull out a y. So this is going to be y, the square root of 2x, y, all over the square root of divide by 2, and so we're going to get the square root, and divide by 2 we're going to get x and y. Okay, so this will stay under. Okay, these will cancel out, and we'll get, if I reduced it all under a single radican, right? Just like that. Okay, whoops. No t in the bottom. Okay. These cancel, so I'm going to get y, the square root of 2. So here the first thing I did was simplify from the 8th root to the 4th root. Now I need a common index, so then we moved over to here, and then viewing it as all under the same radicand, we will simplify, being left with a 2 here, an x here, and a y there. All right, let's look at number 19. Okay, so this one looks a little scarier on first blush than it really is. We're going to simplify the bottom. Here, well, we're going to simplify the top because this is 2 squared, so I'll just pull it out from the radical, and I get 1/2 for the top. For the denominator, this is 2 to the 3rd, so I can reduce the index by dividing both by 3, and I'm going to get the square root of 1/2. Now the square root of 1/2, that's the same as the square root of 1 over the square root of 2, which is the same as 1 over the square root of 2. Okay, so this is critical. Now, so we have now a complex fraction. It really looks like 1 over 2 divided by 1 over the square root of 2. Well, what do you do with a complex fraction? You divide. This is division, so I'm going to multiply by the reciprocal, so that's the same, right, as the reciprocal would be the square root of 2 over 1, right, this reciprocal times 1/2, or this answer here. Okay, square root of 2, which is the same as the square root of 2 over 2. Right? Okay, let's see what else I might want to do. Oh, let's look at 23 just because it's something a little different. And this will be our last one. Again, of course, you could always text me if you're having some other troubles. So 23 will be the square root of 30 minus the square root of 5 all over the square root of 5. Now, of course, we don't want to leave this in the radical. We don't want to leave this radical in the denominator, so we'll need to multiply both the denominator and the numerator by that. When I distribute, remember this is 5 times 6, right? So when I distribute through, I will get 5 the square root of 6 minus 5. And the denominator, of course, now becomes 5. Okay. So if I factored out my 5, I get the square root of 6 minus 1 over 5. 5's cancel, and your answer is the square root of 6 over 1. I'm sorry, the square root of 6 minus 1. There we go. All righty, let's go then to the new idea, and actually I'm going to go to part 2 to introduce the new idea. Actually, let me just give you the answers for the word problem. See if you can't figure these out by yourself if I just give you the equations. Let's finish that up on this. Whoops, hang on. Got a problem, there we go. Okay, so 26. My word problem, the winning baseball team of the National League one year won 22 games more than it lost. So it won what it lost plus 22 more. There's one equation. If the number of games won had been 2 less, okay, and making the number lost 2 more, the ratio of the number won to the number lost would have been 5-4. Okay, so if we have 2 more or 2 less wins, which would make 2 more losses, the ratio would be 5-4. So just go ahead and plug that in with my W and solve that, and your answer should be 92-70. Well, 270 like our ratio. There we go. Okay, and finally 27. A man finds he can reach a certain town in 6 hours by traveling 240 miles on an interstate and then changing to local roads for 80. So we want to know the amount he travels on the interstate. So he would go traveling to 270, on a different interstate and then proceeding. This route saves half hour. Okay, so here we go. We got 240 on this will be the interstate, and 80, this is a portion, okay? Remember, portions in the whole, okay? So that's why we're setting it up like this. So 240 on the interstate, 80 on the local, and what am I looking for here? 6 hours, there we go. I was looking for the number. All right, and then scenario 2, he can also get there by traveling 270 on a different interstate. So what would that look like? 270 on the interstate plus 40 on the local, and he saves a half hour. So he'd now be 5.5. Better use U and V. And, okay, I'm kind of blasting over this for you. Let me just show you where this comes from. Remember, our general equation is going to be rate times time equals distance. Okay, but we're equaling what? Here. We've got the time, so if I solve for that, time would equal what? Distance over rate. And that's what we have here and here. The distance we're traveling, and it says let x and y equal the rates. Okay, so that's why we've got that equation. So we're always back up to this one, and then choose which variable we need to solve for to reflect that back into the equation. All right, so we're going to stop there and do a part 2 for the new idea.